So far, we've met a lot of expressions with exponents in them. For example, 2 to the fourth, an expression that simply defines a number, x to the negative third, and most recently, x to 3/7. Remember, in the last unit we defined these rational exponents in terms of radicals. But all of these expressions have had one thing in common. So far, we've only seen expressions where the exponent is constant. So we've seen some variable bases with a constant exponent. We've seen some constant bases with a constant exponent. An expression with a variable exponent is called an exponential expression. So these two expressions, that they look similar, are very, very different. This expression is a monomial, while this expression is an exponential. And it's going to take a moment to think about just what this means. What does 2 to the x mean if x is a positive integer? Well, that's just repeated multiplication. If x is a negative integer, then 2 to the x means 1 over 2 to the positive version of x. Right, that's what 2 to the power of a negative integer means. And now we know what it means if x is a rational number, then it's just the qth root of 2 to the p. But that's not all the numbers, is it? There are tons of real numbers that are not rational. Well, here's the deal. For any irrational number we can think of, we can get really close to it with rational numbers. And so if we want to work out what 2 to the root 2 is, we sort of fill in the gaps. Right? We can't get an exact value for this number. It's some horrible decimal. It's 2.6 something. Now, let's look for a minute at the square root of 2. The square root of 2 is about 1.414. If I take 2 to the power of 1.414, that's really close to being the same as what we said 2 to the root 2 was. If we keep going a little bit further, 2 to the 1.4142136, we get even closer, though still not quite there. Right, these last two digits disagree. And both of these numbers, 2.414, 2.4142356, those are both rational. So if we want a decimal approximation to 2 to the power of some irrational number, we take a rational approximation of the exponent that's as close as we need to be to get our approximation of 2 to the root 2 as close as we need to be. If we want to think about the true value of 2 to the root 2, well, it's what all of those values get close to.